Good afternoon. Here in this channel, I am going to upload one video on. Uh, I have already started this earlier. Topic is Newton's law of gravitation. Already 6 problems on physics I have uploaded in this channel. So topic is what? Newton's law of gravitation. Okay, this is the topic, Newton's law of gravitation. I think you are familiar with this topic. There are 3 laws of motion of Newton, which are called Newton's laws of motions. There are 3 laws were there, but this law is different. This law says that every 2 objects in this universe attracts each other. Means any object attracts other objects. And he made a mathematical formula for this law, which is called Newton's law of gravitation. Also, it is called universal law of gravitation. Say there are 2 point masses. This is one mass, okay? This is 1 point mass, and this is another point mass. And they are separated by a distance small r from each other. This line is the line of joining the 2 point masses. So distance between the point masses is r. And say mass of this point mass is m1 and mass of this point mass is m2. Okay. If this be the case, then force of attraction between these 2 point masses, F, if the force is denoted by F, then F is directly proportional to the product of the masses, m1 into m2. This is the product of the masses. So for F is what? F is force of attraction. So force of attraction is directly proportional to the product of their masses, and the same force F is inversely proportional to the square of the distance between them. F is what? This is force of attraction. Force of attraction. Okay. So this force of attraction is directly proportional to the product of their masses and inversely proportional to the square between the distance. Okay. So this is also called inverse square law. Inverse square law. Okay. Inverse square law. Because 1 by r is there, so this is inverse, and square is there, so square. Inverse square law, this is also called. Next, the nature of the forces. Number 1, nature of the gravitational force. Nature is what? First, it is central in nature. In the next video lecture, I'll explain all these things. The force is central in nature. This is central force. Second is, this force is conservative in nature. The force of attraction is conservative in nature. Okay, conservative in nature. And this law holds, this force is only attractive in nature. Only attractive. Okay, there is no repulsive force. They don't repel each other. Only force of attraction exists between any 2 masses. So the gravitational force is attractive in nature. So these are the characteristics of the Newton's law of gravitation or gravitational force. Okay, and this law holds for point masses. Okay, point masses, only point masses can be considered while applying this law. While applying this formula, only point masses need to be considered. Okay, so if you combine these two, this one and this one, then what you will get is F is directly proportional to m1 into m2 divided by r square. Right? F is directly proportional to m1 m2 divided by r square. Therefore, F must be equal to a constant into m1 m2 by r square. That constant is denoted by capital G. Okay, so G into m1 m2 by r square. This G, this is called universal gas constant. This is called universal gas constant. Not gas constant, sorry, universal constant, not gas constant. Universal gravitational constant. Universal gravitational constant. Okay, and value of G, Lord Cavendish, by experimentation, he got the value of G, which is equal to, G is equal to 6.67 into 10 to the power minus 11 Newton meter square per kg square. G is equal to 6.67 into 10 to the power minus 11 Newton meter square per kg square. Let me check whether everything is visible or not. Yeah, everything is visible. So this is the value of G, okay, Newton meter square per kg square. And this G is called universal gravitational constant. Why universal? Because this value of G does not change if you go anywhere in the universe. Okay, so that's why this is called universal gravitational constant. And you can see the value of G is so small. Power is minus 11. Power is minus 11. So for objects having small masses, the force of attraction is very small. But for large masses, such as the mass of the Earth, mass of the Jupiter, mass of the Sun, mass of the other stars, for those masses, this force of attraction will be huge. Okay, will be very large. So I think this is part 1 from this chapter. Means lecture number 1 from this chapter. Next, I will discuss other topics from the same chapter. Okay, in new videos. Okay, thank you. Thank you for watching this video.